Good morning everyone, myself Rahul Kurula, and today I am going to take class on Lenz'S Law. Okay, so as I already mentioned in the previous classes that we need to understand the concept of the topic which we are learning. Okay, because if you understand the concept or if you clear the concept, then 90% of our problem will be solved. Okay, rather than going with the definition, first understand the concept, then it will be very easy for you to implement this idea into various applications. Okay, so we'll go with the Lenz'S law. Okay, so as per the Lenz'S law, it states that an induced electric current flows in a direction such that current opposes the change that induced it. Okay, so what the statement means that see, here we can see a magnet, bar magnet. This is north pole and this is south pole. Just imagine like that. Okay, so as you all know that magnetic field direction is always from north pole to south pole, so that we have already marked here. Okay, there is another coil nearby. This coil is connected to a galvanometer, and this can be anything like inductor coil, anything. Okay, this is connected to a galvanometer, and galvanometer we know that it is used to sense the current. Okay, so what happens initially is that we move the magnet, bar magnet, that is from left side to right side. Okay, and moving the magnet from left to right. So what happens, as per the electromagnetic induction which we have learned earlier, the magnetic field lines will get linked with the coil. So what happens, EMF is produced and or potential difference is developed and current will be developed. Okay, so the current direction which will be developed in the coil will be towards the north direction, that is towards the north. Okay, so what happens, as we all know that when a current flows through a conductor, what happens, a magnetic field is developed. So naturally, since a current is flowing through this coil, a magnetic field will be developed. Okay, but since the current is moving towards the north direction, then the magnetic field which is developed here will be in such a way that it will be north here and it will be south here. Okay, see, the reason why the direction of the current is towards north is because we can see that here there is a bar knife, right? That here it is north, here it is south. Okay, so if we move this particular magnet from left to right, since this is north pole here, and if we are moving this bar magnet from left to right, a current is developed and the direction of the current will be towards the north. Okay, so magnetic field will be developed here, and the magnetic field which is developed across the coil will be such a way that it will be in north pole here and here it is south. Okay, so because of this both north pole, this and this north pole, what happens, actually there is a repulsion happening. So what happens, this bar magnet will tend to repel away. It will try to repel away from this particular magnetic field. So what happens, now the magnet is moving from right to left. So now during this time, that is during this case, this is the first case, this is the second case, that is during the second case, when the bar magnet is moved from right side to left side, during this time the direction of the magnetic field will be towards the south. Earlier it was towards north, now it has become towards the south. Okay, it has become towards the south. So now what happens, the magnetic field will be developed across this conductor also, and the magnetic field which is developed across this conductor will be in such a way that it will be here to be south, here it will be north. Okay, so what happens, this is the direction of the magnetic field. Okay, now what happens, because of this south pole and because of this north pole, the bar magnet will get attracted. So what happens, this bar magnet will tend to move towards the right side, and again when the bar magnet moves towards right side, again the direction of current will get reversed, that is it will become towards the north side, that is the current will flow towards the north direction, and again the magnetic field will be developed and it is north pole here and south pole here, and it will get repelled, and the whole process repeats like this. So this is what happens in a Lenz's law. Okay, so this is what they are explaining in the statement, that is the induced electric current which flows in a direction in such a way that the current opposes the change that induced it. So same, this is what we are doing, we have explained here, right? The current, that is when the magnetic field is moved towards this, that a current is developed. This current will oppose the change that caused it, because this current is opposing this magnetic field. Okay, this is what they are saying in the statement. The current in the induced current flows in the direction such that the current opposes the change that induced it. So this is what I mentioned earlier, that is the current will oppose the is opposing this particular magnetic field. So this is what they are mentioned in this particular statement. So I hope it is clear. So thank you.